Welcome back. In this video, I'm going to explain how smoke detectors work. There's two basic types of smoke detectors. There's a photoelectric and an ionization. And first we're going to look at the photoelectric. So the principle is easy enough. There's two basic parts to the chamber of a photoelectric smoke detector, and that's the light source and a photocell. And the way these are set up, the light source is not lined up with the photocell. In other words, if you were to draw, the path of light from this light source, it's not hitting the photocell. The way that these are put into alarm, or the way they detect smoke, I guess I should say, is when smoke enters the chamber. I'm going to simulate smoke here. Let's say this is smoke. The light refracts off the smoke particles. So now the light will, it'll go every direction. It'll scatter, but some of it will hit this photocell. When the photocell sees light, it produces a current, and the circuitry inside the photoelectric smoke detector interprets that current and puts the device into alarm. So if we were to then go and wire this to our fire alarm panel, it would look something, well, it would be powered up the same way these have been all along. This is just a 2-wire smoke detector, I should point out. There are also 4-wire smoke detectors, which the wiring's a little bit different, and I'll explain that in the future. But this isn't going to, once this goes into alarm, it's not going to exactly short out these terminals like a pull station would. It's not a dead short, but it does increase the current significantly, and the fire alarm panel interprets that as an alarm, and the horns go off, etc. All the things we've discussed up to this point. But the thing I want you to focus on is how the device detects smoke. So there's a light source. It's not quite lined up with the photocell. Once smoke enters the chamber, the light refracts off of the smoke, and some of it hits the photocell, and then the device goes into alarm. There's another way to draw this, which I think might make it even a little bit more clear, even though the one that I tried to draw initially, it looks a little more like the devices I'm used to seeing. But if you look at this, you'll see it sometimes when you look this up. It'll be drawn like a T shape. So you got your light source at the top, and this is your light source, and it's going on the top of this T, and your photocell is down at the bottom. And once you get smoke into the chamber, same principle. You spray some smoke, and now the light will, some of that will refract down to the photocell. It'll go into alarm, etc. I think that's easy enough, and I don't want to spend a ton of time on this because there's a lot of information on the internet. You could do a simple internet search and get plenty of explanation of how these devices work. So we're going to move on to the other type, which is a little bit more difficult to explain, a little more difficult to understand. That's the ionization smoke detector. The way these work is there's a radioactive element in all of these ionization smoke detectors, and that is americium-241. And what that element does is it ionizes the air in the chamber, hence the name ionization smoke detector. And bear with me, I'm going to try to explain what that means. So first of all, let's power this up. Same panel, same 24 volts going to our smoke detector, nothing fancy. And that's going to take that power source, or if this were a smoke detector in your house that were only tied to a battery, it would use a battery as a power source. But for right now, we're dealing with conventional systems, commercial systems, so let's take our 24 volts and go to these two metallic discs. So this is now a positively charged disc, and this one on the bottom is a negatively charged disc because we tied it to our power source. And on the right here is a reference chamber, which I'll explain in a minute. For right now, let's just focus on the left. So there are two oppositely charged plates with nothing in between them right now, just air. You can imagine if we had put a light bulb or something on here that it would produce power because current could flow between positive and negative. But with just air in the middle, no current can flow. Except when they put this americium here, what this does is it changes the oxygen, and I guess to a lesser extent the nitrogen that's in the air, and I'll explain that. We haven't really gotten into how current flows on the atomic level yet, but current flows through conductors and not insulators, and conductors have a free electron. So an electron is a negatively charged particle, and what this americium does to the oxygen and nitrogen particles is it actually knocks an electron off of them. And so then the electron, which is a positively charged element, is a negatively charged element, is attracted to the positive charge. So the electrons, which are now free, are flowing towards the positive plate. And now the oxygen and the nitrogen have a negative charge. They have a positive charge because they lost that negatively charged electron. So now they are ionized, hence the name, like I said, ionization, and they are attracted to the negative plate. So before, the oxygen and nitrogen were neutral. Now they are positively charged and they are flowing towards the negative plate. Their newly freed electrons are negatively charged and flowing to the positive side. I know that's a little bit confusing, but you don't really have to understand that. I want to present it that way, but you don't really have to understand that to understand how these things work. The other thing I want to mention is that this radioactive particle has a half-life. I forget what, I looked it up. I want to say it was like 480 years or something like that. So it's not like this is going to work for a year and then run out of power like, maybe like a battery would. So this is going to continuously happen. And what happens is if smoke gets into the chamber, it bonds to the oxygen and the nitrogen, preventing that current from flowing. So in a way, it's almost the opposite of what happens in the photoelectric. Is once current starts flowing through that little cell, the circuitry interprets that as an alarm. In this one, current's always flowing between these plates, and when it stops, that's when the alarm is detected. Now, you see this thing on the right here. That's what's called the reference chamber. That's in most of these the newer ionization detectors. So let's just draw our power over here, and this would be on a very small portion of the smoke detector. I'm drawing it spaced out so it's easy to see what's going on. But this reference chamber is sealed. It basically does not prevent any smoke to get into this chamber. So these two things on the right and left are identical, except that the one in this orange box does not allow smoke in. And the reason they do that is they monitor both of these things. They monitor the current in both of these, the one on the right and the reference chamber. The one on the left and the reference chamber on the right. And the reason for that is things like air pressure and to some extent humidity can affect the current flow. So you imagine a little ammeter in this circuit so that it's actually monitoring how much current is flowing on both of them. And if current stops flowing on on one versus the other, let's say current stops on this one on the left, but it's continuing to flow on the reference chamber, well, it knows that there must be smoke because smoke's not getting in here, smoke is getting in here, and that's what's setting it off. One of the advantages of ionization smoke detectors is that it's not affected by dust because dust doesn't bind to those oxygen and nitrogen particles. So therefore, you don't have to clean them, and I think they're less prone to false alarms. Other than that, it works basically the same way. There is some difference on how they say that, I hope I get this right, they say that the ionization smoke detectors are better at the earlier stages of detecting the earlier stages of smoke, I believe. More of like just I want to say like the smoldering of the smoke, whereas the photoelectric are better when there's thicker smoke, heavier smoke. But there's, like I said, same with the photoelectric. There's a ton of information on this. You could do a simple Google search and get plenty of information, but this is I think this is a fairly decent explanation of how these work. And I guess that's it for right now. I will see you in the next video.